Welcome back to the 16th problem in Blind 75, which is jump game. Let's take a look at the problem. You are given an integer array nums. You are initially positioned at the array's first index, and each element in the array represents your maximum jump length in that position. Return true if you can reach the last index or false otherwise. What are the constraints? It says the nums length is at least 1 and it can go up to 10 to the power 4, and the value in of element in that array can range from 0 to 10 to the power 5, both inclusive. So ideally what we do is we start from the first index and look at the value. Here the value is 2, so it can jump one index forward or two index forward. So it can jump to 3 or 1. And let's take a look at the next jump. So we are at 3. So the value is 3, and it can jump up to 3 steps forward, 3 jumps forward. So 1, 2, 3. So we are able to reach at 4, hence true. Let's take a look at the next example. 3, 2, 1, 0, 4. Start with 3. It can jump up to 2 or 1 or 0. Since it lands on 0, we cannot move or advance to the next element, which is the last element. Suppose we are at 2, it will again land at 0. We are at 1, it will again move to 0. So everything kind of ends at the position where 0 exists, and it cannot proceed further because the value is 0. So it cannot reach the last index. Hence we return false. Let's take a look at how we can solve this. So I have used the same example here. Let's try to write the recursion tree. Suppose this is the starting one, that is 0th index. Everything starts at the 0th index, right? And what is the value here? Value is 2. So from 0 there are two possibilities, right? So it can jump to 3 or it can jump to 1, two positions. So first is the index. What is the value? 3. Or it can jump to the second index. The value is 1. What would happen when we are at the first index? So it can make up to 3 jumps, right? So from 3 it can jump to 1, or it can jump to the next one, or it can jump to the last index. So ideally this would be second index, third index and fourth index. What is the second index value? This is 1. Third index is again 1. What is the fourth index value? 4. So we reach the end of the right index, so it is possible to return true. But let's see how many calculations we might end up doing. Say we are at 2, right? We are at this index 0, 1, 2. So from here it can only make one jump because the value is 1. So 1 to this one, which is third index, and this is 1, so it can only make one jump. So it will reach the fourth index, which is 4. Let's take a look at 2. So this is same, so it can jump 1, which is third index, then fourth index. The value is 1 here and 4 here. And this is 3, right? So from a third index, which is 0, 1, 2, 3, which is 1, and it can only make one jump, so 4. So this is a tree. On this tree, if you reach the last index, that means it can reach the last index and we return from there. So let's see how we can implement it. This is the backtracking method where we try each of the options. So I'm defining a method called jump from position. Can jump from position, where the value is current index, right? if current index equal to len of nums minus 1, that means we have reached the end of the array, so we return true. What we will do otherwise? So there is a small minor use case we need to edge case we need to take care. Say 2 3, the value is 5 here instead of 1 and 4. Okay, so we are at this position. How many jumps it can do? It can do up to 5, right? But can it really do up to 5? No, it can only do 2, because then would become the last element, otherwise it would go beyond the length of the array. So we have to consider that particular use case, and we have to consider this. So we have to take the minimum value of the jump, which is 5 here, or the last index. So here the last index is at 2 jumps, so the farthest jump could be only 2. So that's what we are going to do. Farthest jump is equal to min of current index plus what is the value at the current index, comma len of what is the maximum or the last index. So we will get the minimum value. Then we will try for each index. For I in range of, we would start with current index plus 1, comma farthest jump plus 1. Why plus 1 here? In Python, in range, farthest jump, this value is not inclusive. So I'm adding plus 1 to make it inclusive, make it include the farthest jump. Okay, so what is the, so we have to try this recursive. So if can jump from position of I, that means it have reached, so we will return true. Otherwise we have finished everything and we will return false. So let's call this method from where it will call 0. Let's try this. Yeah. This is a solution but not an optimized one. If I submit, it is going to time out. So let's see how we can improve this. If you take a look at this recursion tree, this 2 3 and 4, like from a position whether it can reach or not is being computed multiple times, right? This is an example, and if you closely note, we also have this 3 4 3 4 computer multiply. Can we optimize it? Yes, we can use memoization to optimize this. So let's take a look at the memoization using dynamic programming, and we'll see how we can do it in a top-down approach first. So let's assume each of the index has 3 states. One is unknown, where we don't know whether it can be achieved or not. The next one is good, that means we can reach that particular index, and the other one is bad, that means it cannot reach. So we'll use these values and use a memoization to track this. Let's implement that. Okay, so similarly, what do we need? We need say def can jump from position. What do we need? We need current index and the memo, right? If memo of current index not equal to unknown, so I'm going to use 3 integer values. 0 means bad, 1 means good, 2 means unknown. We can use the string or anything, so I'm just using the integers here. If memo of current index not equal to 2, that means it is either good or bad. So we will return memo of current index equal to 1. So equal to 1 means true if it is good, otherwise it will return false. what should we do in the other else case? It's the same thing. So farthest jump is equal to minimum of current index plus nums of current index, comma, len of nums minus 1. So we found that farthest jump for I in range of current index plus 1 and up to farthest index plus 1, if can jump position of say I, memo of current index is equal to true, and we will return, we will set it as good, right? Yeah, so the good is going to be 1, so we set it as 1 and return true. Okay, we don't need memo, we will just define it as here, like let's memo is equal to 2 for I in range of len of nums. We'll set each of the value as unknown, then we'll set the last value as good, because we want to see if it is reachable or not. Minus 1 is equal to 1. Okay, so we did that, and otherwise what we will do is we'll set the memo of current index as not reachable, that is 0 and return false. We need to return can, so we'll call this method from the main method, and it starts from 0. Okay, so we are checking instead of doing the iteration whether it is already been visited, and once that is done, what we will do is we'll set it as 1. If it is not reachable to reach the end of the element from a particular index, we set it as 0. That means it's a bad index or a bad position. This is 1 means it's at a good index. 2, we are setting it as initially for all the elements, and we are calling this. Okay, let's see if we can, yeah. So what is the complexity here? So the time complexity here is order of n square. For every element in the array, we are looking at the next nums of I element, so it is approximately order of n square. What is the space complexity? So we are using this memo that is for each element, so order of n for that, and for recursion we might end up using order of n, so it is order of 2n, so we can approximately say it is order of n. So let's try submitting and see if it passes. It seems like it's taking time, so we have to find a different like more optimized solution. We'll look into it. Yeah, so this is a solution, but it's not a good solution yet, so let's see. Okay, so let's see how we can implement the same thing in a bottom up approach. So this is kind of same. Instead of doing a recursion, we do it in a loop. So this is the same concept. So we set it as unknown, and we set it as the last element as a good index. So what we will do is we will do for I in range of, we'll try from the right to the left. So the starting is going to be len of nums minus 2. Then we'll reach like till 0. So we are doing from say 4, then 3, 2, 1 and 0, like this. Okay, so we are we are actually looking from the right to the left. And what is the farthest jump? Farthest jump is going to be minimum of I plus nums of I, comma, len of nums minus 1. The same thing we are finding out. Then for j in range of I plus 1 and farthest jump plus 1, we will, if memo of j equal to 1, that means it's a good index, right? So we will set memo of I also as 1, and then we stop. We are just checking whether that particular index can be reachable or not. So we'll break from the loop. We don't want to keep doing it. So so at the end we will have a array where we will have whether each index is reachable or not. Then what we will check is if memo of 0 is equal to 1. Okay, so this is by this is the iteration from right to the left. That's why we are checking whether we can reach the 0th element. So we start from 4, then go back and we see if we can reach or not. Okay, so that's what we are doing. Okay, so let's try running this. Yep, so this is the bottom up approach, but this might also exceed the time. So we'll try submitting and see. So what is the time complexity? It's the same thing. Time complexity is order of n square because we are doing it for every element in the array. Oh, okay, so this is accepted, but it only beats 10% of the users. So we still need a better solution. So what is the time complexity? Order of n square. What is the space complexity? Space complexity is order of n. Since there is no recursion here, it is going to be just n. So how can we optimize this? If you noted this particular solution, we could find a greedy solution to it. So for a given position, when we try to see if we can jump to a good position, we only ever use the first one, right? So if you remember this, we only check whether it is reachable or not, the first one. That's what we care about. So we could do this in a different way, right? Like an optimized way. So if we keep track of the leftmost good position as a separate variable, we can avoid searching for it in the array. Also, we can stop using the array altogether. So what we do is we iterate from right to left, and for each position we check whether there is a potential jump that reaches a good index. If we reach a good index, then we will set it as a good, and we'll check that that particular index and see if there is a potential jump to that position, and so on until we reach the start of the array. So let's see how we can implement this. Okay. Okay, so we are starting from the last value, right? So target index is len of nums minus 1. So this is a good index, right? So what we are going to do is for I in range of len of nums minus 2 and minus 1 and minus 1. What is this loop for? This is to iterate from right to the left. For example, if 4 is the len of nums minus 2, then it will go for 3, 2, 1 and 0. So that is how the iteration is going to be. Okay, so if the current element, which is target idx, which is if it is less than or equal to the current index plus nums of I, that means there is a potential element from where it could jump to target index. Then we'll set the target index as I. So then it will again look at the next element and keep setting it. So finally, if we get the target index as 0, that means if target index equal to 0. That means we reach the 0th element and return true. Otherwise, we will return false. That's it. So let's try running this. Let's try submitting this. Yeah. So this is accepted, and this is one of a good solution. What's the time complexity here? Time complexity is order of n because there is only one loop here. It starts from the end of the array till the start of the array. So it might stop in before that if it is, if we can't ever reach target index as 0. And what is the space complexity? We are not using any additional space other than couple of variables, so it is order of 1. So that's it. So that's the end of the solution for the problem jump game. I hope you understood this, and please let me know if you have any questions in the comments, and please don't forget to like, comment, or subscribe to the channel. I would really appreciate if you have any feedback. I Yeah, please feel free to give me any feedback if you have, and also if you want me to do any specific topic, um, I'll try to accommodate it. So see you again with another episode of Blind 75. Until then, thank you for watching and goodbye.